So we have our stars and we have our constellations. Now we're able to sort of get a bit of a sense for where we are. What are we looking at? I can say, oh, okay, so this constellation right here looks like Orion. But then immediately it's like, that's not what it looks like in the sky. You know, this whatever star this is way too big, and I can barely see some of the stars that on Orion are from Earth are quite bright. And so, for example, just to double check, we could say take our main camera, and I could zoom in and say, is there a star there? Yes. So the constellation is pointing to a real star that's there. It's just way too small. Every star is being rendered based on how far away it is from Earth, which is an oversimplification of how stars appear in the sky. Because as well as distance, or as well as you can think of a star's brightness as the significant value over its distance. So, for example, there's some really big stars that are really bright, even though they're further away from a small star that's closer. So we're going to look at magnitude and how to implement magnitude in our setup. The first thing I'm going to do is I'm going to make sure that our star info classes have their magnitude recorded. Then we're going to figure out how to put that information into the mesh, so then we can access it in our shader. So I'm going to go ahead and I'm going to open up our coding project. Star info. Okay. So yeah, so this is our project. We've got our HYG ID, our HIP ID, Hipparcos ID. What I'm going to do is I'm going to add two new floats. It's going to be a public float, apparent magnitude. This is a magnitude from Earth, or how bright a star appears from Earth. And there's another float that we'll add here, and this is going to be our absolute magnitude. Absolute magnitude, which is magnitude, actual magnitude. How big this? In fact, it is specifically. It's how bright would that star be if you were 10 parsecs away from it. Okay, so now let's figure out which lines of our star data we need to get that from. I'm going to open up database HYG reference in Markdown preview. Scroll up. Okay, so we have lines. Okay, lines 13 is the apparent, lines 14 is the absolute, and the value type is a float. Okay, so we can say apparent magnitude equals pass utility dot safe float pass, just in case it's not recorded, and that's going to be a lines 13. And the absolute magnitude will be lines 14. All right, so now that that's recorded in our star info class, let's have a look at how to get this into our mesh. I'm going to make just a bit of a note on cross-platform meshes. I've got the intention of eventually putting this on an Android device. So where sometimes, if for example, if we were developing for PC, we could say something like this: mesh.uv2, uv3, uv4, uv5, etc. Usually, if you were to pass data into a mesh that's not the standard mesh data, you'd use one of these further on indices, you know, that aren't traditionally reserved for something else. The thing is that that's not going to work on Android. The Android development. It seems that the best way to do it is to just use the UV property of the mesh to pass that magnitude into it. So let's go ahead and do that. So mesh.uv equals stars dot select new star, okay, star, new vector 2, because a UV is a vector 2, and it's perfect because a UV is vector 2 floats. Now maybe sometimes we want to use the absolute magnitude of the star. If you have it in your mind that you'd like to be able to fly through all these stars, the absolute magnitude is going to make more sense. If, however, you'd like to have a more realistic look from Earth of how the constellations look and the sizes of the stars from Earth, then the apparent magnitude will make more sense. So let's go ahead and pass in the star's apparent magnitude, or apparent magnitude, and the star's absolute magnitude into our mesh. So what we're essentially doing is we're saying okay, Unity, once you've created that mesh, when you're passing that information to the shader, I want you to give the shader this magnitude data as the UV. So we're not using the UVs as you traditionally would for positions on a triangle. Okay. Yep. So that's kind of looking okay. It's a little bit difficult to read. I'll just do this. Like that. All right. So once we have that done, we're going to have a look at our shader. So our star info goes, the information goes from the star info, from the CSV file, to the star info, to the mesh, to the shader. And in our star shader, I'm going to create a new shader. Maybe we want to hold on to this distance only shader. So I'm just going to copy and paste this shader. I'm going to rename this one to distance shader. Distance shader. Shader. I'm just going to make sure that it appears in the menu as a distance shader. Starchart.distance shader. Alright, and now the other shader I'll call a magnitude shader. Magnitude shader. Now the reason why we might want to hold on to this, the reason why we might want to hold into this, because how we're going to create these magnitudes is going to be distance independent, as in it doesn't matter how far away you are from the star, it's going to only depend on that fixed magnitude value to figure out how big it's going to be. Okay, magnitude star. All right. So the first step that we're going to do is we're going to say I don't care how far away the star is. I want you to render every star at the same width. Now, if you're thinking that this might sound a little bit similar to what we were doing with the constellations, you would be right. And this is where the utility class is going to come in handy, because we already have this function get screen scale. From a position in space, I want it to be the same, one that's really far away to one that's really close. I want them to be drawn at the same width relative to the camera. Okay, so how we're going to do this is in our world to clip billboard. This world to clip billboard takes in a scale, and what we're going to do is we're going to calculate that scale. Okay, so we'll say float scale is equal to underscore radius multiplied by get screen scale, which needs the in 0.pos, which is a vector 4, and the fraction. Now the fraction works very differently. At the moment we're saying, I want you to draw a star with a radius of 10 meters or 10 parsecs, which is massive. That was just for the distance rendering. Now we're talking about what fraction of the screen width do you want it to be drawn at. So it's going to be range between 0 and 0. Let's say we had a sensible number for the constellation shader. Let's say 0 and 0.01. I'll say 0 and 0.003. We might want it to be a little bit bigger. Okay, and that's going to by default equal 0.015. And so now we pass in the position as well as this fraction, which is a radius. So I've made a mistake here. I'm not multiplying it by radius because that happens inside get screen scale. Just right here. Okay. Once we have that, we can go ahead and test it out. Right. Okay. So the idea here is that now all of our stars are going to be the same width. Of course, I've renamed the shaders. So in our star material, we're just going to fix that up. Star charts. We're going to use a magnitude star. Okay, let's have a look. What did I do there? Did I do that right? Magnitude star. World to clipboard. Oh, radius. I need to pass in the scale rather than the radius here. Hey, that's a bit big. Okay, so now we have a whole bunch of dots. They're all the same. They're all the same size, which is exactly what we planned. It doesn't look great. You know, it doesn't really. It looks like a bit of nothing. So what we're gonna do is we're gonna pass in that magnitude data. Okay. Another point I want to make is before I do this, I'm going to need to regenerate our stars because our star info object now needs to do some more parsing of that original database. So I'm just going to do a quick regeneration. You might notice as well. Might as well bring it up now. You might notice as well that we've got like this ball of stars, and then there's like this outer ball of stars that's much further away. I'm wondering whether we should do that now. We might as well do it now. Why not do it now? The reason is that how this database works is any star that's that didn't have a position information, or that was too or that was a bad positional information. This database has defaulted it to being 10,000 parsecs away. So you see all these you can sort of see this. I can barely get far enough away from it. See, we have this outer ball, and then we have this inner ball. That's those two types of information. The accurate data and the 10,000 parsec default. So another thing I'm going to do, which I probably should have done earlier, that's all right, is I'm going to go into my star info. Now we're just going to say position equals all of this stuff, and then dot clamp magnitude. How do we do this? We say vector3 dot clamp magnitude position, and the max length is going to be 1,000 parsecs. All right, so that's just gonna fix up this bizarre outer ring of data. Let's do one more generate, and while that's generating, we can create our star shader. Have a look at our star shader. Okay, so magnitude shader. Okay, magnitude should be called magnitude star shader. Magnitude star shader, and I'll also call this one the distance star. Or really, I know I'm changing my mind here. Star distance shader and star magnitude. It's just a bit easier to read like that. Okay, so all of our stars are rendering at the same size. Now we want them to render relative to this this magnitude information that we're passing in. So, very simply, first off, what I'm going to do is I'm going to say bring this app data structure, this is what the mesh is giving us. So we've got the pos, which is position. This would be let's see, this would be mesh dot vertices. That's what that translates to. And now we have our float 2. We're going to call this mag. This is the text coord 0, and that translates to mesh dot uv, which in our case translates to x equals apparent magnitude, apparent mag, and y is equal to absolute. Okay, so we're also going to need to pass it from our, once we have it in our vertex shader, pass it from our vertex shader into our geometry shader. So we'll say float to mag, again text coord 0. In our vertex shader, o.pos equals v.pos, also o.mag is equal to v.mag. All right, now in our geometry shader, we're calculating our scale based on giving them all a uniform scale. And what we want to do in this next part is we want to add in that magnitude into the mix. I'm going to start with something very simple, and then we'll tweak it once we start to look at our values. Okay, so for example, I could say something like this. I could say float screen scale is equal to this, and now we can say float scale equals screen scale multiplied by in 0 dot mag dot x. So we're saying multiply that one consistent value by the apparent magnitude, or the magnitude from Earth, of that star. So let's go ahead and have a look at what that looks like. It looks like red dots. Okay. Okay, so this is because I've renamed those files. We go ahead back into my star material, change that internal error shader into a magnitude star shader. I'm going to change the radius down a little bit, and you can see a sort of a difference here. We'll notice now that now everything's within that 1000 parsecs as well. Now let's have a look. We've got much of a difference. I think there is, but you can't really notice it. See if I can make it more obvious. See, some of the, I don't know if I'll be able to really show the major differences. Some of the stars are slightly bigger than other ones. Now we're going to have to go and do some math to figure out how to get an accurate value.